Section 2.5, limits at and of infinity. So the most basic question you can ask about a limit is, does the limit exist or does it not exist? And if it does exist, and then it's going to equal a number, and you can figure out what that number is. Previously, though, if it didn't exist, that was all we would say. The limit does not exist. In this section, we're actually going to look at ways of classifying limits that do not exist. In particular, you can have them not exist and have no better definition, but other times you can say they go to infinity or to negative infinity. So definition one, if you say that a limit as f of x approaches a number, if you say that that equals infinity, what does it mean for a limit to equal infinity? It means that the limit does not exist, okay? But as you approach that value of p, the values of your function, in other words, the y values you're getting, get arbitrarily large, which means they get bigger and bigger, they become bigger and bigger numbers. And the definition is analogous for limits from the right or left, so a limit as x approaches p from the right. And if you say that the limit equals negative infinity, that means you're getting really large numbers that are negative. So for example, the limit as x approaches 0 from the right-hand side of 1 over x cubed equals infinity, because as you plug in values for x that are close to 0, positive numbers that are close to 0, the value for 1 over x cubed becomes larger and larger. So for example, if you plug in x equals 0.01, you get 1 divided by 0.01 cubed, which is, if you plug that into your calculator, what you end up getting is about 1,000,000. Okay, so when you plug in this number, 0.01 is really close to 0, but it's positive. And when you plug that into the function, you're getting a really big number. So that means you're going to infinity. If you plug in, say, negative 0.01, and you cube that, you're still going to get 1,000,000, except now, because of the negative, that negative cubed means you're multiplying a negative times a negative times a negative. Negative times negative gives you positive. You multiply it by a negative again, and you get a negative. So that would imply that you're going to negative infinity. And graphically, the picture looks like this. Here's 0 right in the middle, and I'm going to graph the function 1 over x cubed. And what it looks like is that as my x values approach 0 from the right-hand side, my y values are going up, up, up to big numbers. And as I approach from the left-hand side, they're going down. Okay, so that is a rough sketch of the graph of f of x equals 1 over x cubed. And it doesn't always look like that. In particular, if you do 1 over x squared and you graph that, it looks like this. From both the right and the left, they're both going to positive infinity, because if you're squaring something, a negative times a negative will give you a positive. So you go to positive infinity over here as well. And this is the type of thing that can happen as you get limits that go to infinity. They're always going to look like that. Definition 3, the limit x equals p is a vertical asymptote of f of x if the limit as x approaches p, either from the right or the left, doesn't matter which one, of f of x is equal to infinity, or if the limit as x approaches p, again from either the right or the left, of f of x is equal to negative infinity. So in these situations where you're going to infinity or negative infinity, that's where you would put the dotted line down the middle to show that you have a vertical asymptote there. So the function f of x equals 1 over x cubed has a vertical asymptote at x equals 0, and as we just saw above, it's also true for f of x equals 1 over x squared. So go ahead and pause the video now and try to look at this exercise, exercise 4, and figure out what that limit is going to be. It's either going to be positive infinity or negative infinity, and you need to figure out why. And then what does that tell us about the line x equals 4? So pause your video now and work out exercise 4. So as x approaches 4 from the right, we plug in numbers slightly bigger than 4. So we're thinking about numbers like 4.1, 4.01, etc. And when you plug in something slightly bigger than 4, suppose you do 4 minus 4.1, for example, that's going to be less than 0. You're going to get a negative number because you're subtracting a bigger number. So in general, 4 minus x is going to be less than 0. It's going to be a negative number as x approaches 4 from the right. And what's more, it gets really small. It gets close to 0. So here, if I plug in 4.4 minus 4.1, I'm getting a negative number, but it's like negative 0.1. If I plug in 4.01, it's negative 0.01. Again, a really small decimal number, close to 0, but negative. Now, what happens if you cube root 4 minus x? Well, you can't take the square root of a negative number, but you can take the cube root of a negative number. And if you take the cube root of a negative number, you still get a negative number. So I have this negative number here. It's small. It's close to 0. When I take the cube root of it, I still get a negative number that's also close to 0. And you can try this on your own. Plug into your calculator the cube root of negative 0.01. You'll see that what you end up getting is a negative number, still very close to 0. And this, so it's still less than 0, and it still gets close to 0. So this implies, oh, and one other thing, so this is all what's going on with the denominator. Now, as x approaches 4 from the right, 2x is just going to equal, well, it's going to approach 8, right? I'll be plugging in x values close to 4, multiply that by 2, I'm getting something close to 8. So we would say that the limit as x approaches 4 from the right of 2x over the cube root of 4 minus x is basically equal to 8 divided by 0. And previously we would have just said, oh, therefore the limit does not exist. But now we're going to go a little bit further. So 8 is obviously a positive number. And 0, it's not exactly 0. Remember, it's getting close to 0, and it's negative. So in that bottom area, we're getting a negative number. So in other words, as you plug in numbers close to 4, your denominator is a small number close to 0 that's negative, and on top you're getting a positive number. So what this means, the 8 divided by 0 tells you that it's going to be infinity or negative infinity. And the fact that we've got a positive divided by a negative tells us that it's negative infinity. And a quick note, if this was the limit as x approaches 4 from the left of 2x over the cube root of 4 minus x, well, if you're plugging in numbers slightly smaller than 4, 4 minus a number smaller than 4 gives you a positive. You would end up getting a positive infinity instead of a negative infinity. In any case, that is our answer. For now, a quick summary of this: if you do direct substitution for a limit, like we did above, and you get a result of form c over 0, here we got 8 divided by 0, this means that the limit is either infinity or negative infinity, and to determine if it's positive or negative, you need to figure out if the denominator is negative or positive as it approaches that value of 0. And then you combine that with whatever your sign is on top.